This is all that's left of my $400 bike. It was stolen right from this supposedly secure room. When this happened, I didn't just get angry, I went to my team.
We are Project BikeWatch, and we're here to mitigate the problem of bike theft on campus. Our team is balanced. Eric will mainly focusing on operations and outreach, Raymond focusing on hardware and robotics, and Ryan will be focusing on firmware and software.
I bring the user perspective and lead the overall vision.
I lead the hardware design, ensuring our product is robust, reliable, and expertly built.
After talking to some peers and doing some research on student papers, we realized that this is not an issue that just happens to us. In fact, 2.4 million bicycles are stolen annually in North America. We have to put a stop to this, starting with our own campus. We started researching and experimenting with how the thieves are able to break in. We found the issue: shimming.
Wait, okay, so shim it and then push it. Easily open.
Yeah.
So as
they
long as
just
you
need to
do
do this from the outside.
Yeah, all you need to do is to pry this thing, and then they have easy access to just shimming the lock.
Exactly.
Show how easy that is, yeah.
It's like a card.
Yeah, it's a lot of attempts to break in.
Yeah.
Sadly, the current solutions, the lock and the camera, both don't work.
As you can see, this spot is not being able to be effectively captured by the camera, right? It's not pointing this way, it's pointing to the door, which only covers this part. So the camera doesn't work.
Also, you need the police to check the camera, and the bike theft is very low on their priority list, which means the victim can be waiting for weeks. So what's our solution?
Imagine if we have a magnet sensor right over here that detects the position of the door. Then beside it, on the frame, we have a reed switch aligned at the same position. So in this case, if you open the door, it detects no magnets, but when you close it, it detects the magnet, and that's our implementation of the door position sensor.
Meet Project BikeWatch, a hardware and software hybrid system that detects a thief and sends an alarm to the staff so they can stop the crime while it is happening.
There are two types of inputs. One is a student car tap, which means the student is trying to get in the room. And two is a door push bar detector, which means the student is trying to get out of the room. So in either case, the alarm will not be sounded for 10 seconds, giving the student plenty of time to enter or exit. However, if the door is not pushed and the car is not tapped, that means the thief is trying to get in. In this case, the door position sensor activates, an alarm will sound, and the front desk will be automatically alerted. And only then, the staff can turn off the alarm. No one else can.
Here's the architecture that uses a unique approach while still maintaining feasibility.
So for the STM32, this will be our main microcontroller for the implementation. While we have the following as the inputs and outputs. First, we will use the reed switch and the door push bar sensor. These will be placed on the door where the reed switch detects using magnetic the position of the door, and the push bar detects if the push bar has been pushed. For the output, we have a horn attached to a MOSFET to ensure maximum loudness and effectiveness while protecting the STM32. For the more advanced I/Os, we have used Ethernet and a key switch mobilizer, where for Ethernet, it allows admin to control and to read the walk card status, while for the key switch immobilizer, it not only detects the key switch position, but also detects if the key is a valid key through its internal chips.
That's a great solution. So what is the projected impact and how can we scale it? In many cases, the bikes that are stolen are never recovered, and that's where we're trying to help on a large scale. However, we do know that we want to start small, so this is our projected impact over a summer. First, we will deploy our MVP. Next, we're going to implement it to the bike room by pitching the MVP to the school, and lastly, to ensure that if a theft happens, we must sound the alarm. Here's how we plan on implementing it. Here are our costs. As you can see, most of the cost is into the 3D printing and also the hardware, which as we scale, it's going to gradually become cheaper to even nothing at all. And we also have a contingency fund for improvement or error handling in case our tests fail. For the first 3 weeks, we're going to purchase all of the equipment that we need and also setting up our development environment. For the next 2 weeks, we're going to solder and print and get all of the hardware stuff done. For weeks 6 to 7, we're going to power the system, run some tests on our hardware, as well as integrate it with our software. Next, we're going to pitch a solution to residents so that we can implement it with an actual bike lock. And then finally, we're going to integrate the alarm as well as conduct some testing of the fully assembled prototype. One main organization that we would like to partner with is Project 529 Garage.
We are a team with a proven solution.
We have the skills, the plan, and the passion.
With the help of youth in the challenge, we will build and deploy Project BikeWatch this summer.